Let me start with the fact that about 100 years ago, there was a huge revolution in science where quantum theory was discovered. And the idea was that people were measuring these various spectral components in atomic processes. And you couldn't really observe the positions and velocity and momenta of these atoms, but you could talk about observables that are the spectral components. And so Heisenberg said, I need a theory that's going to tell me about those spectral components. I can't really measure positions and velocities. And he developed a theory that is structurally very much what is called an operator theoretic perspective on that process. He basically says, what I'm observing is really not a mathematical function. It's an operator. It's really something more abstract. So Koopman understood this and said, hey, if I have a classical mechanics problem, and he worked on these classical Newtonian aspects, couldn't I do the same thing? And he said, here's an operator that could potentially do that. It could take a state of the system at time t to the state of the system at time t plus delta t, sometimes later. You can think of it as a big matrix that just takes the state of the system at time t and ports it to some later time.